Welcome, my friends! In this video, I'll be discussing section 7.2, the chi-squared test. First, we must discuss the chi-square distribution. The chi-square distribution is a skewed right distribution, which can be seen by the image. The distribution only takes on positive values as it consists of squared numbers, and squared numbers will always be positive. The exact shape of the distribution depends on what are called the degrees of freedom, similar to the t-distribution. It turns out that the larger the degrees of freedom, the closer this will look to a normal distribution. In this section, we cover the chi-square or chi-squared test. Actually, both spellings are appropriate, either chi-square or chi-squared. The purpose of this hypothesis test is to determine if two categorical variables are associated with each other. So what do we mean by associated with each other? Well, if two variables have an association, that means the outcome of the first variable tells us something about the likely outcome of the second variable. Let's give it an example. Are highest education completed and employment status associated? We will consider the education levels as either completed high school, completed college, meaning like a 4-year degree, or completed graduate school. And for employment, we will consider people who are either employed or unemployed. If education status and employment level are not associated, individuals of all education levels are just as likely to be employed or unemployed. If education status and employment level are associated, then a person's education status tells us some information about how likely they are to be employed. Typically, the information for a chi-square test will be given in the form of a two-way table. So here we have the highest education level received on the rows is either high school, college, or grad school, and then the employment status as either employed or unemployed. Let's talk about the null and alternative hypotheses for the chi-square test. The null hypothesis will always be that your row and column variables are not associated. And the alternative hypothesis will be that the row and column variables are associated. Of course, you'll be more specific to whatever problem you're dealing with. So for this example, our null hypothesis would be that the highest education level achieved and employment status are not associated, and the alternative will be that the highest education level and employment status are associated. We will be using the Fred technique for all hypothesis tests in this class. So as you may remember, Fred is John Gabrosic's dog, and we have a technique to complete inferential statistical methods using this technique, where each letter represents a different step that we'll be completing. So the F in Fred stands for formulate the problem, R is review conditions, E is execute calculations, and D is draw conclusions. So let's take a look at what this will be for the chi-square test. So if we want to formulate the problem for a chi-square test, we will first describe the population, describe the sample, describe the two categorical variables based on the table, and then set up our null and alternative hypotheses. As for reviewing conditions, something called the expected cell counts has to be calculated, and none of the expected cell counts should be less than 1, and no more than 20% of the expected cell counts are less than 5. We'll talk about the calculation of this a little bit later, but just to give you some intuition about what is meant by an expected cell count, let's go back to the table here. The expected cell count is really saying, what would this table look like if the two variables were not associated? So it turns out if you know the totals, you can calculate how many individuals, for example, you would expect to be have a high school education and be employed, or in college and be unemployed, etc. Right? So the expected counts say, what would you expect this table basically to look like if the two variables were not associated? So we must calculate the expected counts and make sure that none of them are less than 1, and that no more than 20% of them are less than 5, kind of like a sample size requirement. Then we can go ahead and we can execute the calculations for the chi-square test. Now there are formulas that you can use to do this step, but we're going to be using the TI-84 calculator matrix and a function called the chi-square test. Also in this step, we will make a decision to either reject the null hypothesis or fail to reject the null hypothesis by comparing the p-value to the preset level of significance. The p-value will be outputted based on this chi-square test function, and the level of significance will be something given in the problem. It's the type 1 error rate. Finally, we will draw conclusions. And for all hypothesis tests, we will use the same template to draw conclusions. we will first state our level of significance because the decision could change based on your level of significance. So we'll say at the alpha percent level of significance, expressing alpha as a percentage, there either is or is not enough evidence to suggest that, and then we will restate our alternative hypothesis. So when we reject the null hypothesis, then we will say is, meaning there is enough evidence to suggest the alternative. And when we fail to reject the null hypothesis, we will say there is not enough evidence to suggest the alternative. Okay, let's take a look at an example. The following table shows the results of a survey where the highest level of education and employment status were collected for 328 Americans. Use this information to determine if there is an association between highest education level and employment status. So first we will formulate the problem. As part of formulating the problem, we first have to describe our population. And this is a survey of Americans, so we might consider the population all Americans. The sample includes the 328 Americans that were sampled, that we have data for right here. The variables are highest education level achieved and employment status. Finally, we can go ahead and set up our null and alternative hypotheses. Remember that the null hypothesis is always that the two variables are not associated, and the alternative is that they are associated. So our null hypothesis is that highest education level and employment status are not associated, and the alternative is that highest education level and employment status are associated. We have finished step 1. Now, usually we would go on to the second step, which is review conditions, but since we're using the TI-84 calculator to do this test, the expected cell counts, which are what we need to do this step, will not be calculated until the next step. So we're going to come back to the review conditions in a little bit later. So let's go ahead and do the execute calculation step. Now, technically, in order to do this by hand, you would have to use a number of different formulas here, and I'm going to do a little bit with the formulas, but I'm mostly going to focus on the TI-84. But I want to give you some intuition about how this test is done and how we would make our decision based on some calculations. So technically what you would have to do, and technically you would do this in the second step, is you'd have to find the expected cell count for every single one of these values inside the table. And the way you can find the expected cell count is you can take the row total, multiply by the column total, and then divide by the sample size. So for example, the first expected cell count for this cell right here would take the row total, which is 132, multiply by the column total, which is 310, and then divide by the grand total of 328. And we would get about 124.76. Really what that number means is if highest education level and employment status were not associated, we would expect about 125 individuals to be in high school and employed, or have a high school education and be employed, which is not too far off from the actual value that we have observed. So you would have to do that for all 6 of these different numbers. And then you would have to calculate what is called the chi-square test statistic, a value on the chi-square distribution. And this is the sum of the difference between each observed value in the table minus the expected value, which we would have just counted, squared, divided by the expected value. So you would do this calculation for each of these 6 different values, and then you would add them all together. That's what the sum says out front, and that would give you the chi-square test statistic. I'll just show you how this would be done for the very first value. We would take the observed value, which is 120. We would subtract the expected value, which we just calculated over here. We would square that result, and then divide by the expected value, which is 124.76. And that would give us approximately 0.1813. We would do this 5 more times for the 5 other cells inside the table, add those all together, and that would give us what is called the chi-square test statistic. But I'm not going to be doing that. Instead, I'm going to be using the TI-84 calculator because that's a lot of calculations to do. So I will show you now at this point how this can be done on the TI-84 calculator. So if we grab our calculator, we're going to actually have to type this information not into the stat list, but into the matrix. So to get to the matrix, we can press the second key and then the matrix option, which is right here. It's the X-1 key. And then we're going to want to go over to the Edit tab and press Enter over Matrix A. I advise that you always do this in Matrix A. And then you have to change this to match the size of the table that you have, not including the totals. So we have a 3 by 3, so I can change that to 3. Press Enter and change this to 3 as well, and that will modify the size of my matrix. Actually, we don't have a 3 by 3, we have a 3 by 2, don't we? 3 by, let me go back up to this, 3 by 2. And then I'm going to go ahead and type in those numbers. So I have 120, I have 12, I have 100, 4, 90, and 2. The totals are not necessary because the calculator is smart. It can find the totals based on the inside of the table. Okay, then at this point, we can go to the stat key, and then we can go over to tests, and then we can scroll down. And depending on your calculator, you might have 2 chi-square options here. It's the top one, the one that's just called the chi-square test. And then you should never have to change anything in this step here. So it should say observed A and expected B. What it's actually going to do is it's going to calculate the expected values and place them into matrix B. So we can go down and we can calculate. And it's going to give us the chi-square test statistic as well as the p-value, which I'm showing right here. Now, if you go back in your calculator and you go to if you go back into the matrix, so second matrix, you will see now that there is something in matrix B. So if I go down to matrix B, I'm in edit in matrix B. Now I can see the expected value. So we see that 124.76 that we calculated earlier, and we see the same thing for the 5 other cells. And these are all the values you would expect the table basically to look like if the 2 variables were not associated. And we'll deal with those in terms of checking the conditions in just a moment. Okay, so now at this point, we can go ahead and make our decision. So they told us that the level of significance was 0.05, basically saying that we're accepting a 5% chance of making that type 1 error, rejecting a true null hypothesis. Now in our case, our p-value is 0.0552, which is a little bit larger than the level of significance. So I wonder, do you remember what the decision should be when the p-value is larger than the level of significance? Well, you might remember a saying that I used in a previous video. It was, if the p-value is low, the null has to go. And if the p-value is high, the null will fly. So in this case, the p-value is high, as in it's higher than the level of significance. So that means the null will fly, meaning we will not reject the null hypothesis. So I say the p-value is greater than the level of significance, so we are not going to reject our null hypothesis. The claim here that the highest education level and employment status are not associated, we didn't have enough evidence to reject that claim. Now, sometimes if you're doing this by hand, you might have to find an area in the chi-square distribution. It's not really necessary for us since the calculator did this for us. But really, this p-value is represented as a small area in the right-hand tail of the chi-square distribution. So I'm representing this right here, which is also the area to the right of this test statistic. All right, I'm going to go backwards and do the review conditions step. So you might remember that the review conditions, we had to check 2 different things. One, that no expected cell counts are less than 1. I put the expected cell counts here that I just showed you a moment ago in the calculator in parentheses. And none of those are less than 1. The smallest is 5.0488, it looks like. And no more than 20% of the expected cell counts are less than 5. So in this case, there are 6 different values. So if I get out of here, so 20% of 6, 0.2 times 6, would be 1.2. So basically, if we rounded that, like you wouldn't want to have more than 1 of those values be less than 5. And it turns out that none of them are less than 5. These ones are kind of close, but none of the cells are less than 5. So we've met both of those conditions, and we can move forward with the test. Okay, finally, we can do the draw conclusions step. And you might remember that there is a conclusion statement that we're going to use to draw our conclusions. And it says that at the alpha % level of significance, in this case, it is the 5% level of significance. That's the percentage form of this alpha value. And then the template says that you're going to say either there is enough evidence or there is not enough evidence. And then we're going to state our alternative hypothesis. In this case, we're going to say there is not enough evidence because we failed to reject our null hypothesis. When you don't reject the null hypothesis, you should say there is not enough evidence. So in this case, there is not enough evidence to suggest that, and then I'm going to restate my alternative hypothesis. Highest education level and employment status are associated. So based on this test, we were not able to claim the alternative. We did not reject the null hypothesis, so there's not enough evidence to suggest the alternative. All right, here's a problem for you to try. The following table displays movie preference by age of 500 randomly selected individuals. Does the data suggest that age and movie preference are associated? And use a 0.05 level of significance. So go ahead and pause the video and see if you can complete all 4 steps of the Phred technique. So first, go ahead and formulate the problem. And there were 4 different parts to that. You're going to want to skip review conditions initially. You'll want to come back to that after you've done the execute calculations. And then finally, you're going to draw a conclusion and write a sentence out based on that template that we have used. So that's all I had to talk about in this video. So I will see you in the next one.